Let's try today's daily. Okay. It's a graph problem. You are also given a 2D array queries, where each query is one of the following two types. Okay. A maintenance check is requested for station X. If station X is online, it resolves. Okay. Okay. If the station X is offline, the check is resolved by the operational station with the smallest ID in the same power grid as X. If no operation is return inactive one. Okay. Station X goes offline. Okay. Return an array of integer representing the result of each query of type. Okay. In order that appeared. Okay. Power grid is structure in offline. Okay. Okay. Let's see some example here. So if C is equal to 5, so we will have 1, 2, 3, 4, 5 node, and we have the connection between 1 and 2, 2 and 3, 3 and 4, 4 and 5. Okay. And now let's go through the queries. The first query is 1 and 3, and so we search 3 over here. So 3 is online, and the maintenance check is resolved by station 3, so we use the station 3. And for the next, station 1 goes offline. The remaining online is R2, 3, 4, 5. Okay, 2, 3, 4, 5. Next one is 1 and 1. All right. Station 1 is offline, so check is resolved by the operational station with the smallest ID among. Okay. What does that mean by the operational station? Well, okay, and query 2, and since 2, okay, so 2 turned 2 goes offline, and the remaining online station are 3, 4, 5. Query 1, 2, so it'll be 3. Okay, so the output array length should be equal to the queries count, which where the first value is equal to 1, right? Because the when the first value is 2, basically we just have to shut down that node, right? Shut down that station, right? Okay, so connection. Okay, 3. Okay, 1, 2, 3. We have 3 separate nodes, and all right. We got 1, 1, and 1 is on, so just return 1. And 2, 1, we shut down the 1 and 1, 1. Okay, then there is no connected component. So yeah, so I think this problem is a typical union find problem, right? But yeah, I think I'll go with DFS for to find, because we want to find the minimum value, right? And if the root of the union find, the component, is set as false, I think that would be harder to search others, search other oh, actually not, right? Okay, so I think we can use union find and get the set, get components set. So for example, in the example 2, we will have the component like 1, 2, and 3. And for example 1, we will got a component looks like 1, 2, 3, 4, 5. And then basically we just go through the well, and the C is pretty big, right? I think we cannot use DFS of here. It will be TLE. And if we want to use union find, how can we get the minimum available station for the same component? I'm thinking about this. Well, let me implement the union find first. I'm not sure about the time complexity over here. If we have in the worst case, we have n component set, right? Like example 2, we have n component set. And in this case, we have to go through each component set, which is O of n, and to search if the current node is in the component, and if this node is valid or not. If it is valid, it's still online, we can just return it itself. But if it's not, we have to try to get the minimum of this value, right? And in this case, that would be also O of n to, oh, yeah, that would be O of n to transform the set to a, to get a minimum value in the set. That would be O of n, and we have to go through all of the n hash sets, so that would be n squared. I think that would be too big, and in that case, perhaps we need a min heap to store for each hash set. Is that really that complicated? I'm not sure about that. Oh, that's a good idea. I don't. Right. Component sets. Min heap. Okay, let me code first, and if we face TLE, then we just do some optimization. So, all right. So to do the union find, we need parents, and we also need the rank, right? Right. And since that it starts from 1 to 5, it's not 0 index based, and I think we can start with using hash map. That would be easier. So for I is equal to 1 for I in range C, E to C plus 1, right? And parents is I, and it will point to itself initially, right? So, and we have union, and we have find method. Okay. So, yeah, so node, if node parent node is not itself, then we want to find the parent, right? And then we can return the parent node, right? Okay. And for union, we have root 1 and root 2, right? And if rank root 1 bigger than rank root 2, else we want to make the parents of root 2 equals to root 1. And if rank 1 is more than rank 2, we want to make parents root 1 equal to root 2, right? And else we make parent root 2 equals to root 1 and rank for root 2 parents of a rank of root 1 should be plus by 1. And yeah, that's basically the union find, right? Okay, so we can just handle the connection. Okay, over here, UI, okay, U and V in connections, R1, R2 equals to find U, find V. If R1 equals to R2, continue. And otherwise, we want to do the union R1 and R2. Right? Okay, so for now, we have already create a components, right? And we want to make the components into the component set. So the things we can do is that for P in parents, parents P equals to find parents find P actually for P in parents, okay, and then we can have a hash map. Okay. Default date is set for P in for key value in parents.items hm v dot add k, right? Okay, so now we get the components in HMV, and we can handle about the queries now. Q, Q1, Q2 in queries if Q1 equals to 2. We also need a online set true times well, yeah, I think here will be a little bit hard over here. True. Because we need to check the minimum operational station is true or not, is online or not, right? And yeah, so okay. Okay, so what if we maintain a min heap over here? Whew. Min heap v dot heap push k, and we also need a online array, right? True times z plus 1. Oh, if q1 is equal to 2, and we just online q2 equals to false, and else elif equals to 1 and online q2 is true, then result.append q1. Else we want to do the search. All right, and yeah, we need to, okay. So for this search, what kind of things we need? Okay, we want to search. Let me put it here. Okay, search Q1. Q node for for key in hm if node in hm key then we can try to pop out the value right, while min heap 0 online min heap 0 is not true. Min heap heap pop min heap okay, current result is -1, and while min heap and not online min heap and just heap pop, right? And okay, return min heap 0 if min heap else -1, right? Looks good. Oh, min heap v. Oh, okay. Actually, it should be looks like this. Heap push min heap v and k. Oh yeah, this our min heap actually here is a hash map. So min heap key yeah. Whoops, that is wrong. All right. 1, 2, 3. Q1 equals to 1, and online Q2 here actually. Append Q2. Search Q2 actually here. Okay. Expected -1, but I pop out 3. Okay, let me check. Oh, yeah, because okay, yeah. Okay. So if min heap p return min heap key 0. Okay. Oh, please don't TLE, please. All right. TLE, I think. Yeah. There's no connection, and wow. Okay. Well, think the search method is too slow here. Right. Right. Yeah, and that's why I think okay. Okay. Well, is there any way to optimize here? Oh, actually, we don't need to go through each, right? We can just use the Q2 to search the node and get the heap directly. So yeah, so here node for key in hash map. No, we don't need to use the for key in hash map. We can use node find node to get the key. And key. All right. So yeah, well, min heap key and not online. Min heap key. Hip hop. Right? And we can just return if min heap key else -1, right? And that would be faster because we don't have to go through every components. Okay, hope this passes. Yes. All right. Oh, but it's slow, but yeah, whatever. Heap, DFS, BFS, union find. All right. But I don't think this problem is medium because I think usually if we need multiple data structures, and this also a graph concept, so I think this could be considered as a medium hard. I would say, yeah, it's a medium hard for me.